Big news, so there's no maybe about it. This planet is definitely the closest planet to the Sun that's not orbiting the Sun Proxima, so what's the story? Well, it's Earth-like. Yes, what makes Proxima B interesting is that it's an Earth-like planet orbiting the nearest star to the Sun. The James Webb Telescope has just sent Earth a massive warning, and it's getting closer. This warning comes from the exoplanet Proxima B. Every new snapshot pushes us to question more authority. Are terrified each image from this distant planet makes us wonder? These are dangerous pieces of a growing question about an enemy planet near Earth. What if we have a neighboring alien planet that wants to destroy us? Join us in seeing the horrible entities Proxima B hides millions of miles from Earth. A dream or a nightmare? Where are the aliens? That question keeps coming up. Honestly, the universe isn't making it easy to find an answer. We keep throwing our best technology at it, like the James Webb Space Telescope, hoping to catch a glimpse of something, anything that might hint at life beyond Earth. But let's be real. Every new image and piece of data mostly serves to remind us how little we know. We're told that these discoveries could be groundbreaking. Understanding a far-off planet like Proxima B could redefine our place in the cosmos. But while the brains in astrophysics find this thrilling, for most people it's just more space news that doesn't really touch their lives. It's another small step in a giant ongoing search that feels like it raises more questions than it answers. Yet, despite its power, the JWST can only show us so much. We've learned things like the universe being bigger than we thought. Okay, interesting, but then what regarding practical implications? The space between scientific discoveries and everyday relevance can feel as giant as the universe itself. Back to Proxima B, found in 2013 because of its gravitational interaction with its star. For scientists, this was like finding a new cosmic neighbor. The planet is just a bit bigger than Earth and spins around its star every 11 days. The idea of another world so close to ours is exciting on a scientific level, but it's hard for most people to connect with a place that's still 25 light-years away. Imagine being on Proxima B. You'd see its star, Proxima Centauri, as a big dim red light in the sky, much cooler than our sun. The planet races around its star so fast that its year lasts just over a week. One side of the planet always faces the star, getting constant daylight, while the other side is stuck in an endless night. It sounds like something out of a storybook, but the reality of living there would be brutal. The close orbit to its star means any water might boil into steam on the bright side and turn to ice in the dark. Not to mention, Proxima Centauri is not a calm star. It throws out dangerous flares that emit intense radiation. This isn't exactly the neighborhood you'd want to move into. The excitement about finding life beyond Earth really took off in late 2020 when scientists picked up an unusual signal from the Alpha Centauri system where Proxima Centauri is located. The signal had a unique frequency of 982.551, which caught everyone's attention. Recently, the James Webb Space Telescope stirred up more interest by suggesting that Proxima B, a distant planet being studied, might have water vapor in its atmosphere. This discovery is very important because water is crucial for life as we know it. To better understand how much water is present on Proxima B, scientists are using every advanced technique available to them. Spectroscopy, a method that lets them see what gases surround Proxima B, acts like a high-tech detective tool. Atmospheric modeling is another technique that involves creating computer simulations of Proxima B's atmosphere. These simulations help scientists make educated guesses about the atmosphere, similar to how paleontologists use dinosaur bones to imagine what dinosaurs might have looked like. These scientific methods have revealed gases like oxygen, methane, and carbon dioxide around Proxima B, which are essential for life. They also help scientists conduct experiments with different scenarios in their computer models, much like kids playing with different ideas in a science fair project. While these tools are revealing more about Proxima B's atmosphere, they also remind us of the incredible variety of life forms on Earth. For example, extremophiles are tiny organisms that live in the most extreme conditions on our planet. They can be found in boiling hot springs, acidic lakes near volcanoes, and even in the freezing cold of Antarctica. These organisms demonstrate how life can adapt and thrive under conditions we once thought impossible for survival. Chasing life on Proxima B brings huge challenges. Overcoming space travel's greatest problems, However, the challenge of proving life exists on Proxima B is daunting. Not only do scientists have to overcome the significant challenge of intense space radiation, but they also need advanced technology and instruments that can handle the task. The distances involved in space travel to Proxima B are immense, requiring new types of propulsion systems that could transport us across the stars much faster than anything currently available. Ideas like solar sails, ion propulsion, and even theoretical concepts like warp drives offer exciting possibilities for future space travel. These technologies could potentially shorten the time it takes to travel between stars, opening up new opportunities for exploration and discovery. But these technologies are still in the early stages of development and need a lot of research and testing before they can be used for real missions. While thinking about these future possibilities is thrilling, we must stay realistic. The road to discovering life on Proxima B is filled with technological and scientific hurdles. We need to continue improving our technology and understanding of the universe. Only then can we hope to unlock the true potential of distant worlds like Proxima B and possibly find signs of life there. The pursuit of these goals is not just about satisfying our curiosity. It's about pushing the boundaries of what humans can achieve as we reach for the stars. As we think about the long trip to Proxima Centauri, our closest star system, the idea of finding aliens seems less like a wild fantasy and more like a real possibility. This change from being just a story in a book to something we might actually do has gotten some serious thought from groups like Breakthrough Initiatives. They are working hard to turn a journey that would take thousands of years into just a few decades. But aiming for such high goals meets the tough reality of our current technology. Trying to speed up a spacecraft to near the speed of light with what we have now feels almost impossible, like trying to solve a very tough puzzle in the dark. The Alpha Centauri part of the Proxima Centauri system is supposed to take 6,000 years. But then there's the Starshot project, a bold and somewhat reckless idea that wants to use lasers to shoot a spacecraft toward Alpha Centauri. However, many practical issues come up right away. For example, the Earth's atmosphere makes it hard for the lasers to work accurately. A suggested solution involves using adaptive optics, where smaller lasers on satellites would check the atmosphere continuously and adjust for any disturbances. This would help powerful lasers on the ground stay focused on the spacecraft as it flies through space. This laser technique would require an enormous amount of power, equal to the total energy used by the whole United States, and it would work only for a brief time. Think about setting up 100 million lasers over a big area, all to push a small 33T wide spacecraft to 20% of the speed of light. At this speed, the spacecraft would take 22 years to get to the Alpha Centauri system, which is more than many people's lifetimes. But getting to the Alpha Centauri system isn't just about solving technical problems. There are natural obstacles too. The gravity from the sun, bits of space rock, and the giant distance pose big risks. Even talking to the spacecraft would be like sending messages through time, since it would take about 4 years for a message to get from Earth to the spacecraft. Despite all these huge challenges, the desire to explore other stars keeps growing, driven more by our love for discovery and less by practical thinking. As we slowly figure out how to reach Proxima Centauri, the idea of exploring unknown places pushes us forward. Proxima Centauri could have planets like Earth, opening up new places for us to explore. Our search for life has already made amazing finds, peering into the cosmic abyss. Finding planets outside our solar system has already been a big step in exploring space, starting with the discovery of planets around pulsars in 1992. This began a new chapter in our understanding of space, showing that there are Earth-sized planets in areas around their stars that could support life. These planets are found by watching how they interact with their stars. They either block some of the starlight as they pass in front of them, or they make the stars wobble a bit because of their gravity. Our knowledge keeps growing, and tools like the Kepler Space Telescope have been really helpful in finding these distant worlds, helping us learn more about space. Now that Kepler's work is done, the James Webb Space Telescope is ready to take over. It comes equipped with a near-infrared camera, near-infrared spectrograph, near-infrared imager, slitless spectrograph, and mid-infrared instrument. The James Webb Space Telescope is all set to dive deeper into space. It's not just picking up where others left off. It's aiming to go further into the unknown, providing clearer views of Proxima B and the wider universe. Finding life beyond Earth is often seen as a big deal. It's said to change how we view ourselves and our place in space, leading to new scientific studies and deep thinking about life across the universe. But honestly, how prepared are we to actually handle such news? Are we just comforting ourselves with the idea that we're part of something bigger? The voyage of probes launched in 1977 has taken humanity's quest for space exploration to a whole new level, pushing the boundaries of our knowledge and technology. As these probes venture into uncharted territory, they serve as our ambassadors in the cosmos, carrying the message of human curiosity and our insatiable drive to explore beyond our planet. Voyager 1, launched by NASA in 1977, continues its journey through space, providing invaluable insights into the outer regions of our solar system. Equipped with advanced scientific instruments, Voyager 1 has contributed significantly to our understanding of the heliosphere and interstellar space, making groundbreaking discoveries that have reshaped our understanding of the cosmos. The probe's missions have far exceeded their original goals, as they continue to send back data that helps scientists unravel the mysteries of the universe. The relentless pursuit of knowledge and the dedication of space agencies like NASA underscore the importance of these missions in expanding our horizons and inspiring future generations of scientists, engineers, and explorers. While the initial discoveries made by the Voyager probes have already revolutionized our understanding of the solar system, their ongoing missions promise to uncover even more secrets about the universe's structure and origins. The continued success of these probes highlights the remarkable achievements of human ingenuity and perseverance, showcasing our ability to overcome challenges and push the boundaries of what is possible in the quest for knowledge and discovery.